Hello, and today's purpose of the day is I can find the probability of compound events. This includes independent, dependent, and mutually exclusive events for today. Please read the Why section on page 771 in your textbook and answer the following questions, or the Why section is below. Be ready to share out at the beginning of class. Some new vocabulary words. Compound event is made up of two or more simple events. Independent events is two events in which one outcome does not affect the outcome of the other. This means you have replacement of objects. Dependent events, two events in which one outcome does affect the outcome of the second event. This means you are not replacing, it's without replacement of objects, and we'll talk more about what that means on the next couple slides. Mutually exclusive events are events that cannot occur at the same time. And non-mutually exclusive events are events that can occur at the same time. Let's take a look at the probability of independent events. For example, the probability of A and B occurring is equal to the probability of event A times the probability of event B occurring. So let's take a look at the example. A bag contains 6 red marbles, 9 blue marbles, 4 yellow marbles, and 2 green marbles. A marble is selected, replaced, and a second marble is selected. Let's take a look at the first question. Find the probability of getting a blue marble and then a green marble. So the probability of getting a blue would be 9 out of the total number of marbles we have. And we have 21 marbles here. So this would be, blue would be 9 out of 21. Now times, we're going to replace that marble, so put that back in there. So now we'll have 21 marbles to choose from again. And now we want to get a green marble, so this would be 2. And 9 over 21 times 2 over 21 equals 18 over 441, which is equal to 2 over 49, which is approximately equal to about 4.1%. So we're finding the probability, so we'll write our answer as a percentage. Let's take a look at number 2. Find the probability of getting not red and then a blue. So everything that's not red, we have 6 red marbles, so all the marbles that aren't red will be 15 out of 21, because that's the total, and then getting a blue. So we're replacing that marble, putting that back in there, so we'll have 9 out of 21 for blue, which equals 135 over 441, which is then equal to 15/49, which is about 30.6% chance of that happening. And you have to go back to and think, does that logically make sense? Is my answer reasonable, or was something that I did off or calculated off? But these are both correct. Let's take a look at the probability of dependent events. So here would be the probability of A and B occurring, and this is found by the probability of A times the probability of B following A. So let's take a look at an example here. A card is drawn from a standard card deck without replacement. Find the probability that the cards are drawn in the given order. Well, let's first recap about a standard deck of cards. There's 52 cards in a deck. There are 13 hearts, 13 diamonds, 13 clubs, that's my best drawing of a club, and 13 spades. Let's take a look at example 1. The probability of getting a 2, a 5, and then not a 5. And keep in mind here that we are not replacing that card once we take that card out of the deck. So let's figure out the probability of getting a 2. There are 4 2s in a standard deck, so 4 out of 52. Now, will we want to get a 5 on the next card if we draw? We're not going to have 52 cards to choose from because we are not replacing that card. So we're going to keep that card in our hand. So now we only have 51 cards to choose from. The probability of getting a 5 is, we still have 4 5s left. Now the probability of not getting a 5, so we have 50 cards to choose from because we have 2 in our hand. So not a 5, we're going to assume that we have this 2 in our hand, and that 2 is included in the not a 5 category. So there are 4 5s, so 52 minus 4 is 48, but then we're, like I said, assuming we have this 2 in our hand, so that's 1 less than 48, which would be 47 cards to now draw from. That would not be a 5. And we multiply all these events together. because that's the probability of a dependent event without replacement, and we get 752 over 132,600, which the probability of that is 0.6%, which is very low. Think about that. That's less than 1%, which makes sense of getting exactly a 2 and then exactly a 5 and then not a 5 is a very low probability because there's 52 cards in the deck. All right, let's look at the second example. The probability of getting a heart, not a heart, and then a heart. So there are 13 hearts in a standard deck, so out of 52 cards. Now we're going to multiply that by 51 because we have that one card in our hand, 51 in the denominator. In the numerator, all the not a heart cards would be 52 minus 13, which is 39, and then getting another heart. So out of 50 cards, so we are going to assume that we have this heart, that first card, in our hand. So now we don't have 13 to choose from, we only have 12. So I multiply all these events together, and I get 39 over 850, which is 4.6%. The probability of mutually exclusive events. So we want to figure out the probability of A or B occurring, which is equal to the probability of event A plus the probability of event B occurring. And the word or means to add, addition here with probability of mutually exclusive events. So if we look at the first example, a card is being drawn from a deck, only one card. What's the probability that you get a 7 or an 8? And I have this Venn diagram up here to show you that these two events, mutually exclusive, means that they cannot happen at the same time. They are separate. They don't overlap. There couldn't be a chance of them both occurring at the same time. They can't. And like this example here in number 1, probability of getting a 7 or an 8, you can't get a card that's a 7 and an 8 if you only draw one card. So the probability of getting a 7 is 4 out of 52 because there's 4 of them in a standard deck. And then probability of getting an 8 would be 4 out of 52 because there are 4 in a standard deck as well. So 4 over 52 actually simplifies to be 1/13. So that's a probability of getting a 7. And the probability of getting an 8 is 1/13. So we add that together and we get 2/13, which then is 15.4% if you're randomly selecting a card from a deck, and that it will be a 7 or an 8. Let's look at another example. A 6-sided die is rolled. The probability of at least a 4. So at least a 4 means we could get a 4, we could get a 5, or we could get a 6, right? At least a 4. So let's look here. The probability of getting a 4 is 1 out of 6. So one side out of 6. Plus the probability of then getting a 5 is 1 out of 6. The probability of getting a 6 is 1 out of 6. Add those together, you get 3/6, which is 1/2, or 50%. And think about it, if you want to get at least a 4, that means a 5 or a 6. So that's 3 out of a standard die because you couldn't get a 1, 2, or 3. That wouldn't be at least a 4 then. Thank you for listening, and please check Schoology for more information. Have a great day. Bye-bye.